Alright, you guys, so in this lesson we are going over conditional probability, and what that is, it's the probability of event A happening given that B has already happened. So we're going to look at this formula here, and we're also going to take a look at a Venn diagram to see how it relates. We're also going to see how this relates to a real world scenario. So let's consider having to randomly choose a number between 1 and 30. And we're asked, what is the probability that you choose an even number? And I'm going to color code this, given that you have chosen a multiple of 5. So if we know we're choosing a multiple of 5, how many multiples of 5 are in the numbers 1 through 30? Well, we have 5, 10, 15, 20, 25, and 30. So we know that. We're looking amongst about, 6 numbers. So we know we're only considering between 6 numbers since we know it's a multiple of 5. Now, of these 6 numbers, we have to ask ourselves, how many of these numbers are even? So we have 10, 20, and 30. So the probability that we choose an even number, given that it's a multiple of 5, is going to be 3 out of 6. This will be our final answer. So we want to make sure we can see how this relates to the formula. So in our case here, B is the event that we've chosen a multiple of 5. And then both will be this intersection where it's a multiple 5 and it's an even number. So that's our numerator. Okay. And let's take a look at the Venn diagram. What would this look like? Well, our Venn diagram will look something like this. We have all of our even numbers in the black circle. We have all the multiple of 5s in the yellow circle. And we'll have the interlap in green. So we'll notice that since we know, right, we are given that it's a multiple of 5, we're really only focused on this portion of the Venn diagram. We can completely ignore anything that does not fall in either category. And of all of these numbers here, we want to know which ones are also even. So we're looking at this subset, which will be 3 out of the 6, which is the same thing that we have here. All right.